Okay, hello students. Uh, Now I'm going to solve the problem number 9 from chapter 5. So here we have a gravitational force exerted on a baseball is 2.21 newtons down. The pitcher throws the ball horizontally with velocity 18 meters per second by uniformly accelerating it along the straight line for a time interval of 170 milliseconds. The ball starts from rest. Okay, in part A, through what distance does it move before it releases? What are the magnitude and direction of the force the pitcher exerted on the ball? Okay, so let's draw the picture. Now, we know that, okay, just let me clean up. Okay, so basically the ball is thrown from the rest, okay? Here we have V initial, here we have V final. So V initial, if it's thrown from the rest, is 0, and our V final was 18 meter per second, and it was thrown in a time interval of delta t was equal 170 millisecond. Okay, now here we have a ball. Now we have to find first of all the distance before it was released. We have to find a delta x. We also know that there is the force, gravitational force is exerting on the ball. Now first of all, let's find the delta x. Delta x basically can be found by, okay, so I have to find delta x, correct? So we can use a couple of formulas, but for now let me use this formula, which is v final squared. Now you have to keep in mind that it's thrown to in horizontal x direction. Okay, so that means v final squared is equal v initial squared plus 2a delta x. Okay, now from here, if you want to find delta x is equal v final squared plus v initial squared divided by 2a. Now our 2a is equal, okay, our a is equal v final minus v initial divided by delta t. Okay, so if you plug it here, you will get that v final plus v initial, v final minus v initial, okay, divided v initial, okay, v final minus v initial over delta t. So this one will go with this one away. We still have here 2. That means your delta x will be equal to v final plus v initial delta t divided by the 2. So let's plug the numbers. If you plug the numbers, then delta x is equal, v final is 18, v initial is 0, divided by 2, and multiplied 0.17. Okay, so let's do calculation. If you do calculation, 18 multiplied 0.17 divided by 2. So it means we will get 1.53 meters. Okay, our delta x was equal to 1.53 meters. Now, then we have to find what is the magnitude and direction of the force the pitcher exerted on the ball. Now, first of all, let's find the acceleration. Okay, now the acceleration can be found by this formula. A is equal v final minus v initial over delta t. So our v final was 18 minus 0 divided by 0.17. Correct? So if you do calculation, 18 divided by 0.17, we should give you 106. Okay, 106 meter per second squared. Now after that, what we have to find? Now after that, we have acceleration. Okay, let's find let's find the force. Okay, now since if object is moving only in horizontal, okay, if it's moving in the horizontal, we can calculate what is the horizontal force which is exerting on the ball. Now that means we can say that our Fx is equal MAX, right? Do we know the M? No, we don't know the M, but however M can be found from the let me clean up this place. So our M can be found from the Fg is given, which is equal to 2.21 newtons, which is equal to mg. Now if you want to find m, that means Fg divided by the g. If you plug the numbers, then you can see that 2.21 divided by 9.8, you will get that the mass of the ball is equal 0.225 kilogram. Okay, so that means we'll bring it here. 0.225 multiplied acceleration x direction is equal 106. So multiply that one to 106. You should get that the force in x direction is 23.9 newtons. Okay, now so what is the magnitude and direction of the force the pitcher exerts on the ball? So that means if the ball is moving horizontally with the force of Fx, which is equal to this one, and our Ax is also found, now you have to exert a force on the ball in such a way that your resultant force will make sure that it's flying in the positive x direction. So that means the pitcher has to exert this force, right? Has to exert this applied force so that we have a g force, which is pointing exactly downwards. Okay, right? So that means the ball can fly only in positive x direction. So how can we find it now? How can we find F applied? So F applied, again, so this is our Fx, which was equal 23.9, and then we have Fy, which is our Fg. Okay, so that means using the Pythagorean theorem, we can say that F applied should be in such a way that Fg is equal 2.21 squared plus 23.9 squared under the square root. So if you do calculation, you will find the 2.21 squared plus 23.9 squared. So you will get almost 24 newtons, right? So that means the pitcher has to apply 24 newtons so that after the releasing the ball will fly only in horizontal direction. Now how can we find the direction? So how can we find the theta here? In order to find the theta, we know that theta is equal inverse tangent Fg divided by Fx. Okay, so that means if you plug the numbers, inverse tangent, now Fg is equal 2.21 divided by 23.9. Just one moment. Divide by 23.9. So we'll give you 5.28 degrees. So this theta This theta was 5.28 degree. So that means the pitcher has to throw the ball by 5.28 degree from the horizontal, okay, upwards, so that after the releasing, it will fly only in X direction or in horizontal direction.